Tonight, we settle in for a journey through the seasons, the quiet, ancient rhythms that orchestrate our world. The slow, steady dance of light and shadow constantly reshapes everything in existence, from the subtle warmth of growth to the profound stillness of dormancy. Each cycle writes a new chapter in the story of life. Across the great expanse of the oceans, through deserts, and deep within forests, the same invisible pulse moves beneath everything. This force pulls the tides, directs vast animal migrations, and colors the skies in patterns older than human memory. The very stars seem to align with this tempo. Even the air we breathe and the deepest cycles within our own bodies are intimately connected to the rhythm of the seasons. For now, just focus on your breath. Allow your eyes to grow heavy, and let the planet's perfect rhythm carry your thoughts. It is soft, endless, and completely reliable. Let us begin this exploration. The seasons on Earth exist because our planet's rotational axis is inclined at approximately 23.5 degrees. This slight tilt is the hidden mechanism behind every instance of warmth, cold, and varying daylight we encounter. Because Earth is slightly slanted as it makes its way around the Sun, solar energy is distributed unevenly throughout the year. For example, during June, the northern hemisphere leans towards the Sun, receiving more direct, concentrated rays, resulting in intense heat and long days. 6 months later, the same regions cool down dramatically as they lean away, and the Sun hangs lower in the sky. This fundamental geometry creates the 4 seasons and meticulously carves out the world's diverse climates. Every modern calendar, every cultural tradition, and every moment of weather is a subtle echo of this universal, celestial lean. If that vital axial tilt were to disappear, most of Earth would be perpetually suspended in a single, monotonous climata, permanent spray, or autumn. A planet spinning perfectly upright would be frozen in time. The Sun would rise and set in nearly the exact same position daily. Day length would be constant, and the entire concept of a season would cease to exist. Earth's tilt is therefore not a minor detail. It is a fundamental planetary heartbeat that keeps all living systems cycling, renewing, and thriving with every lap around the star. Should Earth's tilt ever increase by even a few degrees, summers would become dramatically hotter, and winters would freeze entire land. Such an increase would transform Earth into a world defined by violent contrasts. Polar areas would receive direct, continuous sunlight for months, causing massive ice melt, only to then plunge into profound darkness and extreme cold. Our current tilt exists in a fragile equilibrium, balanced perfectly between chaos and stability. The moon acts as a gravitational anchor, stabilizing Earth's tilt. Without this companion, our seasonal cycles would swing wildly over long stretches of time. The moon's immense gravitational pull prevents the Earth's axis from drifting dramatically over thousands of years, a phenomenon that is known to occur on other planets like Mars. Every gentle spring and harsh winter we experience is dependent on this quiet, cosmic partnership. Earth, like a massive spinning top, slowly oscillates, subtly shifting its angle of inclination every 41,000 years. This slow, elegant movement, termed axial obliquity, changes the angle by a few degrees. When the tilt steepens, the seasons intensify. Summers become hotter, and winters grow colder. This immense rhythm contributes to the Milankovitch cycles, which are the dominant forces guiding Earth's long-term climate behavior. This ancient, predictable wobble has historically played a crucial role in triggering the planet's ice ages. When the axial tilt decreases, the contrast between summer and winter softens. Snowfall from winter fails to melt completely during the mild summer months, leading to a gradual buildup of glaciers that reflect vast amounts of solar energy back into space, thereby plunging the entire Earth into an ice age. The equinox is the precise moment when the center of the Sun crosses Earth's equator. In that fleeting instant, the planet's axis is aligned neither toward nor away from the Sun. Theoretically, day and night are perfectly equal in length, though this moment of true balance passes quickly. The term solstice originates from the Latin phrase meaning the sun stands still. The solstice marks the point when the sun's visible path across the sky reaches its peak northern or southern limit before beginning its reversal. The summer solstice in June brings the longest period of daylight in the northern hemisphere, while the winter solstice in December brings the shortest. Throughout history, sophisticated ancient cultures utilized the solstices to pinpoint the transition of the year and celebrate the return or waning of light. Sites like Stonehenge, Machu Picchu, and Chaco Canyon were engineered to precisely align with solstice sunrises, echoing this fundamental human connection to the sun's movements across vast distances and millennia. During the winter of the northern hemisphere, the Earth is actually at its closest point to the sun in its orbit. The planet reaches its closest orbital distance, or perihelion, in early January, right in the middle of the coldest northern season. However, this minor distance variation has negligible impact on temperature. The warmth we associate with seasons is almost entirely disconnected from our proximity to the sun. Seasons are instead dictated by the angle at which sunlight strikes the surface and the resulting day length. When the sun is high in the sky, its rays hit the surface directly, concentrating energy and delivering warmth. When the sun is low, the energy is spread thin across a larger area. The northern hemisphere warms and cools more rapidly due to the large presence of landmasses or continents. Since most of the planet's solar land is situated north of the equator, seasonal thermal changes occur more sharply there. This geographic reality results in dramatic temperature swings and heavily influences the annual fluctuation of atmospheric carbon dioxide as vegetation experiences stronger yearly growth and decay cycles. Summer in the northern hemisphere is approximately 4 days longer than summer in the southern hemisphere. This slight inequality occurs because Earth moves slightly slower when it is farthest from the sun in its elliptical path. This small difference can impact global weather patterns, including ocean temperatures and monsoon timing. Seasons are always opposite across the equator, yet they are intrinsically linked by the single axial tilt. When the north experiences summer, the south is in winter. The two halves of the planet exchange roles every 6 months, maintaining a warm-cold balance that stabilizes the Earth's total climate system. Animals that cross the equator during migration experience opposite seasonal signals. Birds, certain whales, and butterflies follow immense routes that require them to pass from one set of seasons to its exact opposite. These journeys effectively create a living biological bridge, connecting the climate patterns of the north and south. The Arctic Circle defines the boundary where the sun does not set during the summer solstice, providing weeks of 24-hour perpetual daylight, known as the midnight sun. Conversely, the Antarctic Circle marks the boundary where the sun fails to rise during the winter solstice, leaving the icy landscape under deep twilight or shadow for many weeks. This period is known as the polar night. Some cultures living near the equator acknowledge up to 6 microseasons, which are tied primarily to rainfall and successful harvest cycles. In these regions, the seasons are defined not by large temperature swings, but by the onset of rain, prevailing winds, or the readiness of specific crops, reflecting a deep, intimate understanding of the local ecology. In Japan, the traditional calendar breaks down the year into 72 subtle seasonal shifts, known as the Shichiju Nikaiyo. This system divides the year not into 4 quarters, but into 72 periods, each lasting about 5 days, used to celebrate the transient beauty found in small, natural changes. Australia's indigenous calendars frequently track animal and plant behavior as the definitive markers of seasonal change, rather than relying on temperature alone. Each region possesses unique seasonal periods defined by ecological signs, such as the synchronized blooming of particular flowers or the predictable return of migratory birds. In Finland, the slow, lingering period between major seasons is so significant it has its own name and is the focus of festivals. This transitional time is called ruska, a term that describes both the rich coloring of autumn leaves and the gentle, reflective mood that precedes winter. The spring equinox can technically fall on different calendar dates depending on your time zone. Although the equinox is a singular, universal moment in space, the arbitrary division of Earth into time zones means that the exact date can appear to vary globally. Saturn's massive tilt causes its famous rings to appear perfectly at June, only once every 15 Earth years, as the planet follows its 30-year orbit. Twice during that period, the rings align precisely with Earth's viewing plane, making them nearly invisible through telescopes. This slow, elegant oscillation defines Saturn's unique planetary rhythm. Uranus rotates almost entirely on its side, resulting in 42-year-long periods of light and darkness. Its axis is tilted more than 90, causing the planet to essentially roll around the Sun. For decades, one pole is perpetually bathed in daylight, while the other remains in total shadow. This prolonged exposure creates uneven heating, causing dramatic shifts in cloud and storm patterns as the equinoxes slowly arrive. Neptune's seasons span decades because its orbit takes 165 Earth years to complete. With an axial tilt of about 28, it experiences distinct seasonal periods, but each one lasts for over 40 Earth years. Changes in the planet's methane clouds and strong winds indicate which hemisphere is currently receiving more warmth. It would take multiple human lifetimes to witness a single spring on Neptune. Even tiny, distant Pluto experiences seasons that cause its atmosphere to freeze and then return. As it approaches the Sun during its immense 248-year orbit, its frozen surface of nitrogen and methane begins to sublimate directly into a thin, temporary atmosphere. As it recedes, these gases refreeze onto the ground as a layer of frost. Some exoplanets experience seasons that last for centuries. Worlds orbiting other stars may have elliptical orbits so stretched out that one part of the year brings devastating heat, while the other plunges the planet into hundreds of years of freezing cold. On these distant worlds, the spring season could easily outlast the entire documented history of human civilization. Astronomers can even detect seasonal color changes on distant planets as shifting clouds, storms, or ice coverage are reflected in the light detected on Earth's seasonal carbon cycle is visible from space as the world's forests green and then fade. Each spring, as sunlight intensifies across the northern hemisphere, vast forest systems burst into photosynthetic activity, drawing massive amounts of carbon dioxide out of the atmosphere. This massive biological effort measurably lowers global carbon levels. When autumn arrives and leaves decay, that carbon is released back into the air, creating a measurable, visible planetary heartbeat synchronized precisely with the seasons. Every spring, colossal plankton blooms in the oceans, absorb billions of tons of carbon. As light returns to high-latitude waters, microscopic algae multiply by the trillions, effectively drawing vast quantities of carbon dioxide from the atmosphere and into the sea. These seasonal blooms are vital carbon regulators, having an effect comparable to global forests, while also sustaining entire marine food chains. The Arctic region is warming at a rate 4 times faster than the global average, entirely altering its seasonal structure. This extreme acceleration shortens winter and extends the thaw period, causing sea ice to form later and retreat earlier. The polar night is measurably shrinking as open water absorbs more heat, delaying ice formation and extending twilight. This rapid transformation is not isolated. It generates ripple effects that impact ocean currents and weather systems across the entire globe. Certain migratory bird species are now arriving weeks earlier than they were 5 decades ago. Since spring temperatures are warming sooner, insect populations are hatching ahead of schedule, forcing birds to advance their long-distance journeys by more than 2 weeks in some recent decades. Migration was once perfectly synchronized with the steady rhythm of the seasons. Now, it is a desperate race against a rapidly changing clock. The seasonal temperature swings directly influence patterns of disease, agricultural production, and animal migration. Earth's seasonal tempo dictates when food will grow, when animals will move, and when pathogens will flourish. The timing of allergy seasons is shifting as global temperatures rise, causing pollen counts to peak earlier and remain high further into the fall. In urban centers, the vast heat retained in concrete and stone blurs traditional seasonal boundaries. Pavement, brick, and glass absorb solar energy during the day and release it slowly at night, creating the well-known urban heat island effect. This localized warmth mutes the sharp transitions between seasons, causing spring frost to arrive later and flowers to bud significantly earlier along city streets. Earth's axial tilt even impacts how orbiting satellites generate solar power throughout the year. Near the solstices, some spacecraft spend extended periods in Earth's shadow, which reduces the electrical power available. Even the International Space Station experiences seasonal lighting patterns. Spacecraft bound for Mars must launch during specific, narrow seasonal windows for the proper planetary alignment, an event that occurs approximately every 26 months. Scientists can accurately date ancient ice layers by counting annual melt and freeze lines deep inside glaciers. The alternating bands created by summer melt and winter freeze trap tiny bubbles of ancient air, dust, and pollen, preserving an unbroken record of Earth's atmosphere. The most continuous ice core retrieved from Antarctica provides a climate record spanning over 800,000 years. Every ring within a tree trunk marks a complete cycle of the 4 seasons. Inside every tree lies a detailed record of its life, beginning with the light, wide growth of spring and summer, followed by the darker, denser wood formed in autumn and winter. By comparing overlapping ring patterns from different generations of trees, researchers can accurately reconstruct climate conditions stretching back thousands of years. Coral skeletons record seasonal ocean temperatures. Year after year, corals slowly construct limestone skeletons that grow layer by layer, much like tree rings. Warm seasons result in lighter, less dense bands, while cooler periods form darker, more compact layers. By extracting small cores from living corals, scientists can reconstruct seasonal changes in ocean climate over centuries. Even cave stalagmites contain annual bands that clearly trace ancient rainy and dry seasons. Inside limestone caves, water dripping from the ceiling leaves behind thin layers of calcium. Wet seasons deposit thicker, quicker forming layers, and by analyzing these bands, scientists can reconstruct long-term climate patterns, detailing the rise and fall of monsoons and droughts stretching back 500,000 years. Seasonal ice melt is now exposing ancient landscapes that have been hidden for tens of thousands of years. As immense glaciers and ice sheets retreat, they reveal terrains that have been buried since before the rise of human civilization, offering scientists a precious glimpse into Earth's climate before the last ice age. Every heartbeat, every breath, and every harvest on Earth ultimately traces its existence back to the quiet, powerful rhythm of the seasons. The subtle tilt of our planet dictates far more than just the daily weather. It shapes the fundamental conditions that allow life to flourish. This seasonal tempo is the planet's pulse, ancient, unceasing, and shared by every living thing. To inhabit Earth is to move in profound harmony with this great, unending cycle. Hygabobeus. The Earth is still turning, its axis leaning softly, tracing a constant, invisible path through the heavens. This slow, beautiful turning of the seasons will continue, carrying you gently into rest and into your dreams.